This is Fusion Capitalism, a clean energy vision for conservatives. Brought to you by industry leader and company CEO, Steve Malink. Here's Steve.
Thanks for joining me on the first episode of Fusion Capitalism. I started this show to talk about one of the most critical issues of our time, climate change. And my guest is one of the leading climate scientists on the planet. His name is Mark Jacobson, and he's a professor and researcher at Stanford University. Mark, thanks for joining me today.
Yeah, thanks for having me on your show.
So let's start from the beginning. I understand your life path changed due to a trip to LA with your tennis team as a kid. Can you take us back to that day and tell us about how it inspired your career?
Yeah, well, when I was around 13 years old, I used to play tennis, and I would travel to LA and San Diego and play tennis tournaments. And I just noticed in both Los Angeles and San Diego, the air was just really filthy, especially over the freeways. And I just thought to myself, why should people live like this? And I felt this is really an important problem to solve. And kind of as I aged, I kept thinking back to that and thought this is something I want to do in my life, to understand and solve large-scale air pollution and then ultimately climate problems. And so I felt I had to understand the problems first before I could try to solve them.
And I understand you've been named one of the world's 100 most influential people in climate policy. Can you tell us maybe who are the people who inspired you during your journey that you've been on?
Well, just to give you a summary, I went to college at Stanford University, but there was no air pollution major and no climate major. So I studied civil engineering, and that was close to groundwater pollution. I did a master's in environmental engineering, which is in groundwater pollution. And then I did a PhD at UCLA in atmospheric science, where I actually did study air pollution and built a computer model to simulate air pollution in Los Angeles. And I then, after that, went to Stanford as a faculty member and started and expanded that computer model to make it into a global climate model that also evaluated air pollution and weather at the same time. And so I was able for 20 years then to study the causes and interactions of air pollution and climate problems and interactions between them. And it was in the late 1990s that I started looking at solutions as well. And one of my mentors, actually as an undergraduate at Stanford, was Professor Gil Masters, who had taught courses on renewable energy back in the early 1980s. And I remember those courses. And in fact, when I started looking at solutions, the first thing I looked at was wind energy. And I remembered a class that he had taught me in 1983 and 4, where he'd actually developed this nifty equation to evaluate the efficiency of wind turbines. In fact, any wind turbine in the world, he could evaluate based on just 3 simple parameters. And I used that information to write a simple paper that he helped me co-author to look at, is it possible to transition most of coal in the United States to wind power? That paper got published, and it got a lot of negative feedback by people, especially in the coal industry, who didn't like the fact that you could replace coal with wind. But that was really just the start of the journey to try to understand the solutions to climate change and air pollution problems.
It seems like here in the U.S., we have a basic education problem. There's, I don't know what percent of the population that seems to understand climate change, the basic science of it. If I can try to summarize it, and you correct me how I might go wrong with this, but the problem is we're burning fossil fuels like coal, oil, and natural gas, and emitting the byproducts of that combustion process, carbon dioxide, into the atmosphere. And the accumulation of this CO2 over years and decades is creating this blanket-like effect around the globe and creating a greenhouse gas effect. And we know what greenhouses are. They create warm environments for plants to grow even during the wintertime. So that's what we're virtually kind of creating for planet Earth. That, in effect, is creating rising air temperatures, and therefore ice is melting and sea levels are rising. Then there's feedback loops as well. Like I guess the permafrost is melting and releasing methane into the atmosphere, creating a greenhouse gas that's even worse than CO2, many times worse, my understanding.
Yeah, well, that's a relatively good summary. So greenhouse gases are basically gases that are transparent to sunlight. So sunlight just penetrates right through them like it does in a greenhouse, but opaque to heat radiation. The Earth itself emits heat radiation back to space. So if you have a gas that traps that heat radiation, the radiation can't escape. The radiation then stays near the surface and heats the surface. So the more greenhouse gas you add to the atmosphere, the more trapping of heat you have near the surface and the planet warmed. The additions I'd make are that, well, CO2, carbon dioxide, is the major human emitted greenhouse gas in the atmosphere, but it only causes about 45% of global warming. And then the second leading cause of global warming is actually not a gas, it's actually black carbon, which is a particle component. It's the main component of diesel exhaust. When you burn diesel or jet fuel or kerosene or even biofuels or biomass, you emit this smoke. And the smoke, if it's black smoke, that's black carbon. And if it's brown smoke, that's called brown carbon. Brown carbon also heats, but not quite so much as black carbon. Well, it's about 17 to 20% of all global warming is due to this black carbon from diesel exhaust and from jet fuel and biomass burning. And those particles, though, don't last in the atmosphere very long. And so it's a short-term effect. However, they're continuously emitted, so you always have some in there, and they're per unit mass. They're actually like 1,000,000 times more powerful than carbon dioxide warming the planet. So even though black carbon is much more powerful at warming the planet than carbon dioxide lasts a lot longer. It lasts on the order of 50 to 100 years in the atmosphere, whereas black carbon might last a few weeks. And so it's a trade-off between the short-term very strong effect of black carbon and the very long-term weaker effect of carbon dioxide. And by the way, black carbon it's not a gas. It operates in a different way than CO2 because it absorbs sunlight directly. It's not transparent to sunlight. The reason it appears black is because it sucks up sunlight and doesn't transmit any color or radiation, so that's why it's black. Whereas greenhouse gases are transparent to sunlight. And then when black carbon absorbs that sunlight, it then heats up and then radiates that heat around it in the air. Well, anyway, the other greenhouse gases are, as you mentioned, methane. There's also nitrous oxide, which is a lot from fertilizers. Methane comes not only from combustion, but also leaking from landfills, termites, from rice paddies, and also natural gas, like fracking. There's a lot of leaking when you produce natural gas. And natural gas is mostly methane itself. So if that leaks to the air, then you get a lot of methane. And then also chlorofluorocarbons, which are refrigerants that were used, they were mostly banned, but they're alternatives to chlorofluorocarbons that are also have caused global warming. Anyway, those are the major components.
So why has this become such a problem to understand? It sounds like it's well understood as a science, and for whatever reasons, it's become kind of a political hot potato. And given the potential effects of climate change over the years and decades ahead, you would think that smart people would rally around this and try to become part of the solution.
Yeah, well, it's because then there's a lot of money invested in fossil fuels. And so that's what's driving, people are contrarians. The fossil fuel industry has funded studies that try to dismiss the impacts of global warming or even to dismiss the fact that it exists. And then they also fund policymakers who, to basically try to, it's kind of like an indirect bribe to say, look, we're going to fund you if you don't pass any legislation against global warming. And so this then gets into the general public. It's kind of like the tobacco issue where tobacco, everybody knows, causes cancer and kills people, but the tobacco industry for a long time minimized its impacts, and then there's a big PR campaign. It's the same thing with global warming. It's not that 97% of scientists know that global warming exists. It's 99.9%. There's virtually nobody who's a credible scientist. In fact, and there's nobody who actually is capable of studying the issue who says that global warming doesn't exist. It's usually the scientists who actually have never built a climate model, have never run a climate model, and who don't actually take data. They're usually in different fields, like they might be in geography or something, that they're anti-global warming. There are very few. You can almost count them on one hand of scientists who actually are capable of studying the issue, who claim that global warming or try to minimize global warming.
Okay. Well, interesting. So when you're building these models, it sounds like you've been involved with this for many years, if not decades. Do I understand that correctly? And that you're constantly having to refine the model over time as data becomes known and slightly different with what the model forecasted? And to what degree accuracy can we say these models are?
So I developed models for air pollution, weather, and climate. And so I built a climate model from scratch. And so I've been doing that since 1990, so about 30 years. The results of these models are very clear that not only is global warming occurring, but it's actually much worse than most people think, because pollution particles like black carbon and well, are not only enhancing global warming, there are also a lot of pollution particles that reflect sunlight back to space that are actually offsetting some of the warming, causing cooling. So as we clean up air pollution, we're going to find that global warming is actually going to get worse in a lot of places. I think global warming is actually much worse than most people think. But the key is the solutions. How do we solve the problem? And so for
Yeah,
the last 20 years, I've been looking at solutions to the problem. And the nice thing about solutions is that more people believe in the solutions than even believe in the problem of global warming. For example, it's ironic. There was a public opinion poll of about 26,000 people in 13 countries. 80 to 82% of the people believe that going to 100% renewable energy, which would actually solve the global warming and air pollution problems, is a good goal. However, only about 66% of the same people, believe climate change is an important international problem. However, from my point of view, it's really, if they believe in the solution,
sure.
which is renewable energy, yet don't believe in the problem, that's fine. I mean, because we want to
Hmm.
solve the problem. If we solve the problem, then it doesn't really matter if they believed in it in the first place. So that
Sure.
makes me feel good that people want to solve the problem, or at least want to transition to clean renewable energy, which would not only solve the global warming problem, but also save the 7 million people who die from air pollution each year worldwide, and also create jobs, reduce the cost of energy, and increase international security.
So it sounds like the economic opportunity of clean energy is starting to dwarf the perceived problem of climate change, is what you're saying. Is one of the problems with that, though, is that if the problem isn't fully understood and appreciated, that the federal government will never get behind a clean energy vision and plan and help lead the clean energy revolution of the 21st century.
Well, I think the problem is well understood among scientists and among a good portion of the public, and there are certain people who are still denying the solution. However, what you say is partly correct that, well, the federal government will respond to constituents. Now, it turns out in the United States, 9 out of the 10 states with the largest amount of wind, actually installed wind power, are all Republican states or controlled by Republicans. So there's actually a financial interest in both parties, the Republicans and the Democrats in the United States, for example, to move towards renewable energy. This is not only with regard to wind, but also to solar. So you can get a lot of movement. However, the thing is, we need to do this much more rapidly than most people think. So we need at least an 80% transition of all energy sectors in the United States. That's electricity, transportation, building, heating and cooling, industry. We need 80% of that to be transitioned to clean renewable energy within 10 years by 2030, and 100% no later than 2050, but hopefully by 2040 or 2045. And so to get that rapid pace of transition, you do need federal government action. And it does help to have a motivation like global warming, but there are other motivations, such as air pollution. In the United States alone, 78,000 people die from air pollution each year. And there's also energy security and also the cost of energy. From our own studies and many other studies, we find that it's actually cheaper to transition to clean renewable energy, much cheaper, because when you actually electrify everything, which is part of this plan, if you convert everything to electricity, so for example, you have electric cars, some hydrogen fuel cell cars, or hydrogen fuel cell trucks and long distance aircraft and ships, for example, where the hydrogen is produced from electricity, where you use electric heat pumps instead of gas heaters in your home, where you have electrified industry for high temperature processes instead of burning coal, oil, and gas to get high temperatures. When you electrify everything, you reduce energy requirements about 60%. So even if the cost per unit energy is the same, you have a 60% lower energy cost. That's what happens when you transition to clean renewable energy. You drop your energy costs substantially, but you also reduce your climate costs and your health costs. And on top of that, you create more jobs than you lose. And you create this energy security because you have more what's called distributed energy. The solar is spread out. Right now, if one coal plant or one natural gas plant goes down, or one nuclear plant goes down, that takes out the power for a whole city. But when you have hundreds to thousands of individual generators, wind turbines and solar panels spread all over the place, that means that if a portion of them go down, you still have the rest of them working.
Yes, that makes sense. Did I hear you say earlier that there are 7 million air pollution deaths per year?
Yes, worldwide, there are 7 million. This could be an underestimate. And that's like, it's the second leading cause of death worldwide.
It makes the current COVID-19 crisis that we're in today look small in comparison, but it doesn't have the awareness that the pandemic does.
Yeah, well, most of these are in developing countries. As I mentioned, in the US, it's about 78,000. In Europe, it's about 300,000 deaths. But like in China, it's over 1.1 million deaths per year. And in India, it's similar in many countries where, and a lot of it's indoor burning of coal and wood and dung and biomass for home heating and cooking. Of these deaths, about 20% are children under the age of 5 years old. And often their immune systems get compromised due to the air pollution attacking their systems. They end up dying of pneumonia because their immune systems are so weak.
So you say that we need to be at 80% renewable energy by 2030. Would you say that without government intervention that the free market will get us there? Or do we quickly need the U.S. president and administration and Congress that fully supports a clean energy platform?
Yeah, well, this transition is going to occur at multiple levels. So it'll occur at the individual level. So individuals can do things in their own homes, such as transitioning, when their gas water heater burns out or when they want to change it. If you, instead of getting another gas heater, you get a heat pump water heater. The same thing with air heating. You get a heat pump air heater and air conditioner because heat pumps use 1/4 the energy as gas or even electric resistance. And then, next car should be an electric car using energy efficiency in your home, like it with LED light bulbs, transition all your light bulbs to LED. Next refrigerator should be a very energy efficient refrigerator. Things like that people can do in their own homes. But then we do need policies in place to speed up the transition. And it's not necessarily that we need money. We could have mandates that where we just mandate a transition timeline, and then we have all new, for example, in California, like all new homes in 2020, that's this year, have to be zero net energy. So that means you pretty much have to put solar on the roof of every new home. If we mandated all new vehicles to be electric by, let's say, 2023, and vehicles turn over 15 years, basically we'd have 100% renewable vehicles by 2038. And we could speed that up. But my point is you can require things to be transitioned in a certain timeline. By the way, to transition the entire United States, which is basically the cost of a US Green New Deal, it would be an upfront cost of about $7.8 trillion. And that sounds like a lot, but we spent $2 trillion just in the last stimulus. That would be 1/4 of the entire transition of everything in the United States to clean renewable energy. But we'd reduce, as I mentioned, if we do transition in the United States, we'd reduce the cost of energy, the annual cost of energy by 60%, due to the fact that you're using about 57% less energy, and there's another 10% reduction of the cost per unit energy by transitioning. You're saving a huge amount of money, and so it pays back over time very quickly.
Mark, stand by for a moment. We have to pause right here. But coming up in part 2 of my discussion with Mark Jacobson, a professor and researcher at Stanford University, Mark will tell us about some of the advantages of clean, renewable energy.
People who have rooftop solar, they can own their own power. There's a good portion of people who don't believe in climate change. They don't even believe in health problems, but they do want to own their own energy. And having solar on your roof is one way to own your own energy and have the government not have so much control over you.
Thanks for listening to Fusion Capitalism. To find out more about Steve Malink and his book, go to fusioncapitalism.com. This has been a production of Forbes Books Radio.